Okay. Hello. Welcome to the Korean SAT Math Experience presented by DrZye. Now, disclaimer, today's talk is about nice math questions. I will mostly be saying positive things about the math questions. That is not my opinion on the SAT system as a whole. I spent 3 years of time in the system myself, so if anything, I would happily watch it burn. Now, anyways, I have translated the 2019 Suneung Math in English and gave it to you, to the DrSwap Math Club. DrSwap Math Club. Suneung is the Korean SAT, because that's the one I took 8 years ago in November of 2018. It's called 2019, but it's taken in the year before. Anyone watching this can try it yourself in zai.world/suning. That's Suneng in English. That's why it's Suneng. You can also try any of the other past Suneng math exams because I've been translating most of them in the last few years. I've also given the math club what I think to be the hardest question in Suneng math history as a challenge. It has a very beautiful solution. I'm going to talk about this problem first in today's talk. Now, let me put this here so that the people watching this on YouTube can have some time reading it. And here, today's talk will have either 2 parts or 3 parts. First part, I'm going to solve that problem. Second part, we're going to go through the entire SAT math exam I had to solve. And if we have time after that, DrSwap once said, what if we have to solve the problems in Korean too? And it's a great idea. The math club really likes a challenge like this. I've prepared a set of problems in Korean that I think makes sense as a decipher challenge. Everyone will turn on their mic. I'm going to share an Excalidraw link with the problems, and I'm going to let you do your thing. Sounds exciting? Okay, let's start. And by the way, you can stop me at any time and ask me any question. Because first, I'll give you some world building. What's the culture behind this exam? Now, from now on, imagine that the world of Suning is like a fictional fantasy, a fairy tale. In this fantasy world, there is a single deity called Kais. It's the institute that makes the exam every year. In this world, every year, Kais bestows 3 holy scriptures down to us mortals. They are called the mock exams, 2 mock exams in June and September, and then the real exam in November. These 3 tests are considered as part of the canon. They form the basis of what you need to study for the SAT. I mean, of course, you need to study the school textbooks as a baseline, and there are practice books designated by the government as well. But anyway, the prior KAIS exams are thought to hold absolute authority. Other institutes give out mock exams too, but these are not considered to be canon, only the ones made by KAIS. And it's that way because the quality of the exam questions is actually different. It's actually really hard to replicate Kais's style. There are thousands of private tutors selling thousands of private exams to students, but only few ever get close. I would say in this fantasy world, the tutors are like wannabe oracles. They try to earn trust from students, give them hope, prophesize what Kais would do that year, something like that. But still, tutors are not Kais. Nothing they say is really canon. Kais exams are just like an untouchable platonic ideal, at least for the characters in this fairy tale. Of course, this is a small fairy tale called SAT Math in the much bigger world called the entire college entrance system, because there are many ways to get to college with less focus on the SAT. Anyway, are you immersed in the world building now? Then let's get into the problem. By the way, any questions up till now? You can ask me anything about the Korean and college entrance exam or whatever. What about? Let's see. Let's look at the chat. Yeah, this is the Korean version of College Board. Bum bum bum. I mean, yep. I don't know what College Board is exactly, but I think that would be the case. Anyway, this
Sounds like
problem
it to me.
is yeah. This problem is well made in the sense that it rewards mathematical intuition and creativity. There are many ways to solve it, and in every step of the solution, there exists a way to save time and do less calculation if you have the right intuition. Now, today I'm going to solve this problem with as little calculation as possible, mostly using visual explanations. Of course, in the constraints of the actual exam, it would be realistically not feasible for a high school student to find every single time save that I'm going to explain. Because when I first tried this question while I was in high school, I believe it was the summer of 2018, around 6 months before I had to take my SAT. Yeah, at the time I had none of the intuition, and I wrestled with the problem for a full day. Uh, but today I will just take the role of someone visualizing the ideas behind the problem. Let's hear what 3 Blue 1 Brown has to say about visualization. Uh, 3 Blue 1 Brown says,
ask the question, what does it look like? I'm not saying every single piece of math has to be visualized. I'm not even necessarily saying visualizing it will always give you the best explanation. But what's undeniably true is that there is a lot of low-hanging fruit simply asking the question, what does it look like?
okay, so I'm going to ask the question, what does it look like every single step of the question, and just solve it like that. Okay, let's go to the question. Bam. And okay. Now, I believe there are a few people here who have tried the question beforehand, and I believe there are people here who got it correct. So, do you have how did you like approach this problem at first? What did you think about it? You can answer it like in the chat or like with your mic on. Anything is okay. And I'll just do things. Oh,
I saw
sorry.
geovector Bardic function, and I saw that f of x would be a rational function. And at that point, I was like, oh, this is going to be much harder than I anticipated. And I sort of just gave
Oh,
up.
right. Yep, this part, x minus a fx equals gx. Wait, my thing is bugged. Wait. Okay. Why does it not follow my mouse? Okay, now it's following. Let's follow. Okay. Now, this part, let's read it from the beginning. A function fx defined on x larger than a, so it's just a function, and a quartic function gx with a leading coefficient of -1. So if you don't know, a quartic function is a function that kind of looks like this. We're doing a visual explanation here, so yeah, it kind of has ups and downs. It has like 2 ups and 2 downs, or it could have like it could just go like that. This bumps could differ in their size, but anyway, it can have at most like these 2 bumps, and at least it has like this 1 bump. Anyway, it has a leading coefficient of -1, which is why it goes like that. It goes down like this. Yep, that's the part. That's the first part. And now it looks like x minus a times fx is gx for all x larger than a. For all, that's just the entire domain. So fx is just gx divided by x minus a. And that's why it's a rational function. Fx is some sort of like quartic function divided by x minus a. Now, here, I'm going to ask, what does it look like? What does fx look like? But not in the usual sense, like not in the usual sense of what does the graph of fx look like. I'm going to instead ask, what is the meaning of this expression visually? What is the meaning of gx divided by x minus a? Now, I could give you some time to think about what the meaning is. Bam, 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 bam. Now, Valo says, is it Val0? Val0 says, if G has a pole at A, then F is continuous. If not, it has a pole. Right, that is also correct. Like this thing, the shape of this thing matters whether Gx has an x minus a term in it or not. Right. But unrelated to whether gx has that or not, this can be thought of as something relating to a line. Can you guess what it is? Something relating to a line. Maybe it's better if I write this. Now, this is what we call a slope. It's a slope from the point a comma 0 to the point x comma gx. Right? Did you get that? It's, yeah, x minus a, gx minus 0. And that kind of gives us a nice intuition on what fx is. It's always a slope from the point a comma 0 to the point x comma gx. I went in thinking f and g were polynomial, so I assumed probably incorrectly that g equals f with another root at x equals a. Yep, that is an assumption you can make, but unfortunately in this problem it turns out to be wrong. Let's kind of try to think about what this means. Now, I'm gonna, okay, my hands are shaky, wait. Here's the point a comma 0. This is the x-axis. Now imagine gx looks like, I don't know, anything like this. Let's just think about a single point, x comma gx. Now, fx at x, fx would be the slope of this line. Now, that is all we can get from this a at this point. We're gonna go to b. Now, b is where things get really interesting.
Where does that a0 come
Oh, yeah.
from? Where does that a0 come from? Because I feel like f of a is just going to be undefined, bro. No.
Oh, what I'm saying is that f of x is equal to the slope of this line, given that this point
Oh,
is
I see. I
x
see.
comma gx.
Okay, I see. Okay. So you're taking the
Right.
derivative basically at a specific point, not in general. Is that right?
No, it is in general because that's like the definition of a slope. This is like basically x2 minus x1 and y2 minus y1.
Oh, I see it now. Okay.
Yeah.
Yeah, I see it now. Okay.
Okay.
All right. Yeah.
Great. Now, okay, let's go to b. For some real numbers alpha and beta, the function fx has a local maximum of m at both x equals alpha and x equals beta. Now, a local maximum is something like this. This is a local maximum. It's the largest part, like it's the largest point nearby. Usually, like for a continuous function, like a local maximum happens when you increase and then decrease. Now, fx is a slope between this point and this point. Now, what does it mean for fx to have a local maximum? What does it mean for fx to possibly like increase and then decrease? Imagine, wait. Yeah, imagine this line is the line between a comma 0 and alpha comma g alpha. Now, f of x, the slope of the line, has to somehow increase while gx, like x, while x goes this way, and then decrease while x goes this way. How can that happen? What do you think will happen to gx for that to be true? The slope has to increase and then decrease. The slope is kind of like the angle here. It's not exactly the same, but like it's a tangent of the angle. But anyway.
X equals g of x, bro.
Yes. Okay, Vol0 says GX also has a maximum nearby. And what did you say? I couldn't hear it very well.
F of x would have to equal g of x, and then g of x would have to be like concave down.
Yeah, it has to be like concave down, which means something like this. Because this is the only way for f of x, for the angle of this to be, whoops, to be angle to be less than this in this area, and then it also has to be less than this in this area. So the angle has to be kind of maximized in this point and then decrease again. So all this boils down to this line from a comma 0 to the gx function has to be tangent to gx at that point. And gx has to go down like this. That's what it means by fx having a local maximum. Now, I'm gonna assume you got that and move to the next part, which is fx has a local maximum at both x equals alpha and x equals beta. Now, that would mean at some alpha, this line will be tangent to this alpha at this point. And at some beta, this line would also be tangent to gx at this point. And now, notice how it says it has a local maximum of m at both x equals alpha and x equals beta. The value in that local maximum is the same for both of these both of these values, which means the slope of the line from a comma 0 to alpha comma something, and then from a comma 0 to beta comma something is equal. What does it say about the 3 points, a comma 0, alpha comma thing, and the beta comma thing? Yeah, they are aligned. Yes, that's correct. Now, the only way for the slope to be equal is that if the 2 points alpha comma g alpha and beta comma g beta are both on this line. And we know that it has to be tangent like this in both points. So now we kind of know the shape of gx. That's what B tells us. And I kind of skimmed over it, but the reason this line goes up like this, in the positive direction, is because this m is larger than 0. Now, that's all we got from B, and we're going to move on to C. The number of values of x where fx has a local extremum is greater than the number of values of x where gx has a local extremum. Now, what does that mean visually? Fx having a local extremum, that's either a local maximum or a local minimum. So if it's a continuous function, it means like it increases and then decreases, or it decreases and then increases, one of the two. Now, we already know that f has a local maximum here, has a local maximum here. What happens to x on all other values? Like, let's kind of draw this gx thing like all the way through. And let's think about how this line behaves. Now, bam. Okay. At first, the line kind of could go to negative infinity. If gx passes a comma 0, then something weird happens. But anyway, in our current drawing, it kind of goes like this. Zoom, zoom. The angle keeps growing and growing. And then here, this is the first part where it changes direction. It decreases. And then it's kind of hard, but something happens when this line is tangent to gx. This line also has to be like tangent to gx at some point in here, like at this point. And then after passing this point, this line has to go up again. And then after this part, the line kind of goes down again and down and down and down, probably to negative infinity. So I think what happens is that fx changes direction 3 times in this drawing. It starts like negative infinity or something. It goes up. it meets here, it goes down for a slight bit, it meets here, and then it goes up again, meets here, and then it goes down for the rest of eternity. So I think the number of values of x where fx has a local extremum is 3. Fx changes direction 3 times. Okay. Bam. Now, this has to be greater than the number of values of x where gx has a local extremum. Gx can only be one of two kind of like in two shapes. Gx can change direction 3 times. Wait a bit. Gx can change direction 3 times, or it can change direction only once. It goes up and then down. So Gx has either 3 local extrema or 1 local extrema. And because this is 3, that means this has to be 1. Wait for a bit. My web is lagging. Yep, this has to be 1. Okay. Now, do you have any questions in that part? I probably may have skipped over the part where gx passes through a comma 0. That is a possibility that I have skipped. You kind of need to realize that in that case something weird happens at this point also, like and it kind of becomes impossible for there to be two values like alpha and beta where fx has a local maximum in this drawing. Like this kind of has to be how gx looks for there to be two of these bumps where this line meets gx. Now, I'm gonna assume that we now understand how gx looks. Gx has to meet this line somehow in two places, both tangent, and gx cannot have more than one place where it changes direction. So like this part cannot go down too much. Like this part cannot be shaped like this. It cannot be shaped like this because it goes down and up here, and that gives too many local extrema. So anyway, now we know that gx looks like this. And that's basically all we get from A, B, and C. And then the question asks, given that beta minus alpha is equal to 6 root 3, compute the smallest possible value of m. Now, m is the slope of this line. M is the slope of this line. We know that alpha and beta are points where gx is tangent to the line. And we now know that this is 6 root 3. And from here, all we have to do is try to somehow make this situation into an equation and then solve that and get the smallest possible value of m. Let's try that. Let's try that. Okay. Let's try that. Now, gx, I'm gonna do some trickery here because all of this is pretty advanced, but I promise that I'm going to show you like the shortest path to the answer, the most visual path. So what I'm going to do is this. I could do something like minus x4 plus, I don't know, bx3 plus cx2 plus dx plus e and try to solve what these variables are, but this is too much. That requires too much computation. So what I'm going to do instead is try to make it as simple as possible, try to make this expression as simple as possible before putting in these numbers and trying to solve things. I see that people are typing in the chat. Do you have any ideas?
I guess maybe you can look at the tangency of alpha and beta, and if you have because you have m, maybe you can maybe you can write a nice thing for f and therefore get something nice for g, or something like that.
Right. You can get something nice for f because you have the tangency, or something nice for g. That is pretty much true. Yeah, you can get something nice for g using this condition. Val0 says we can subtract alpha times x so that alpha and beta become maximums, and we can take the derivative and solve equals 0. I believe you are saying you can subtract this line. You can subtract this line maybe so that alpha and beta become maximums. I think I understand what you're saying. Gx is some quartic function with -1 as a leading coefficient. If you subtract m, yep. You could take the derivative of g and subtract m to get zeros at alpha and beta. Yeah, that's true. Just a quark. Yep. Alpha and beta are no longer maximums after you make the subtraction. Uh, I think what they're saying is this: like, imagine you take the you subtract this line and this function. Like, imagine at each point you calculate this distance.
Yeah,
And this
never
distance,
mind,
yeah,
it does
becomes
work.
0 here and here. That distance is going to look something like, I mean, technically the negative of that distance, but whatever. It's going to look something like this, with alpha here and beta here. And this is still a quartic function with a leading coefficient of -1. And that means we can write it something like this. This line, this is has a slope m, and it passes through point a comma 0. So it's basically y equals m to the mx minus a. And if we subtract gx from, if we subtract that from gx, then we are supposed to get this function. And we know that that has a -1 coefficient. And then we know all the 4 solutions to the equation. Like, it has alpha twice and it has beta twice. If you don't know, that's like if it ever meets this thing in like this fashion, it has at least 2 solutions in alpha and beta. Yeah. Yep. So we get this. And we can just move this there and get that.
Should it ever be x minus alpha cubed and x minus beta to the 1, or the other way around?
Wait, I'm sorry.
So
Could
it's
you
x
repeat
minus
that?
alpha squared and x minus beta squared. You have x minus alpha cubed and x minus beta to the power of 1.
Oh, right. If you have x minus alpha to x minus alpha cubed and x minus beta to the 1, then it's gonna look like this. It's gonna look
Oh, okay,
like
okay.
this. Yep.
All
The shape of the graph differs by how many solutions you have at that point. Now, this is like ideal enough for us to proceed. But I promise you that I'm gonna do the one with the least calculations. So here's what we can do further from this equation. We can simplify this even further, which is that, you know how it says beta minus alpha equals 6√3, and all we need to compute is m. Now, what that means is the exact position of, like, the exact absolute position of a, alpha, and beta. These things are not important in getting the solution at all. All that's important is that this difference is 6√3, and that difference is gonna somehow decide how gx as a graph looks like, and that's gonna be enough to give us the smallest possible value of m. So we can put in alpha and beta whatever values we want, given that they differ by 6√3. And if we do that time save, if we somehow get that intuition and are able to make a time save, then we can put in values here that's gonna simplify this equation as much as possible. What do you think? What do you think are the values we can put in? They have to be values that differ by 6 root 3. Let A equals 0, alpha equals 6 root 3, beta equals 12 root 3, says Sunny. That's a good idea, but unfortunately, I don't think we know yet whether A and alpha differ by 6 root 3. I don't
We could do
think, yeah, I don't
Oh,
think
I
that's
was right. I was acting under the assumption that it wouldn't matter. Then we can
right,
just
right.
let alpha. Let's just let alpha be 0 and beta be 6 root 3, or
Yep,
maybe
that's
negative
we could
3
do
root
x
3.
minus mu minus 3 root 3 and
right,
x
right.
root 3.
Yeah, yeah, yeah.
Or yeah, x minus 3 plus 3 root 3.
Yeah. There are two ways to do it. You can do 0 and 6 root 3, but I think in the end, what gives you the least amount of computations is negative 3 root 3 and positive 3 root 3 because they like cancel each other out, and yeah, they just become x minus 27 squared, right? Negative 3 root 3, positive 3 root 3. Yeah. And then I guess we are trying to find out the
I think
largest
it's
value of
negative
m.
x squared minus 27 squared.
Oh, sorry. Yeah, that's true. Yeah. And that is the simplest way we could write this. I mean, the simplest way I know that of writing this equation. And then we could maybe differentiate this once and try to find the maximum value of m. Yeah. We know, like, the only thing we have left is that the number of values of x where gx has a local extremum has to be 1. And the way to compute that is to differentiate gx and find out where its like local maxima and stuff are, and have the have it have less than 3 real solutions. Like the derivative of gx is a cubic function. If this thing has 3 solutions, then gx has 3 local extrema, and if it has less than 3, like if it has 1 solution, then gx has 1 local extrema. So we need this function g prime x to have less than 3 solutions. Okay, let's calculate g prime x. G prime x minus, this is just going to be m, equals, we are going to do a little trick here. We do that, and then we do x squared derivative, that's 2x. No. We can put this here, just plus m to this part, and let's move it down here so we can look at it better. Yeah. Now, it all comes down to have this thing have this equal 0 at less than 3 points. Now, this thing looks like this. I mean, this part. Wait, it looks like this. I think this part can be simplified. I mean, not simplified, but if we move this over, it simply becomes 4x times x squared minus 27. Oh, hello, Carrie. We are just almost at the end of solving the hardest problem in Korean SAT math history.
Hello,
Now,
Zye.
hello. This part looks like this. Bam, right? This part looks like this. And we need it so that the solution to this equation has less than 3 solutions. So m has to be like, what, this or something. Yeah. It can be here, it can be here, it can be here even, because that gives us 2 solutions, but it cannot go any further below. This is y equals m. Okay, so I believe we are supposed to find the smallest possible value of m, and m is larger than 0. So the smallest possible value of m is going to occur when this is m. So now we have to find out the greatest, this local maxima of this graph, and then just calculate m. Okay, how do you calculate the local maxima here? You just differentiate it again. I mean, there are techniques like about they're like things about cubic functions that you can use to derive it faster. What is happening? Error, error. Okay. Plus, wait, I don't even need to do that. This is just faster. This is just faster. And then we get 4 times 3x squared minus 27. That equals 0 at x equals plus minus 3. This is going to be x equals minus 3. We put that in here. That's going to give us m equals 4 times minus 3 cubed minus 27 times minus 3, which is 27 times 2, which is 54. 54 times 4 equals 216. And that is the answer to the hardest problem in SAT Math, Korean SAT Math history. Bam. Any
Yay.
questions? Bam, bam, bam.
I think the really, at least unintuitive part is putting this as a slope, which is something I think it just makes sense only in this one specific scenario where you're like dividing by x minus a. So it's very
Right,
interesting.
right. Yeah, I mean, I agree that that's the most unintuitive part. Like even in most solutions, like there are textbooks meant for students that have solutions to these questions. Even they like don't really solve it that way. They don't really try to solve it that way because probably the people who wrote the solutions thought it was too unintuitive. So they usually just like differentiate the both sides of this to kind of get like things about FX. Kind of, yeah.
I would assume doing this the bashy way is not completely infeasible, but like just doing this would be like if you just want to improve your SAT score, this would be like it would be useless to present such a solution in a textbook because it doesn't tell you how to get more SAT grades.
Right, right. Yeah. I I think like because of this problem, like this was like a completely new meta at the time. This was in the November of 2016 for the 2017 SAT. And these kind of problems were never the meta at that point. Like this just came in like and just smashed all the competition for the hardest problem in SAT math, and then like it's still a legend. Nowadays, the meta has changed a lot, and SAT math do not have these kinds of extremely hard questions anymore. But anyway, yeah, that was it. Okay, I deleted all that because it kind of takes up too much of my memory, I think. Okay.
It's
And
just a
now,
storage, which
right.
means it's just a storage, which means that if you refresh, I believe it will be gone. But if you don't refresh, it's fine.
Oh, okay. I am currently wait. I think I'm currently sharing the screen between sharing the Excalibur draw between my Windows and my iPad, so I don't think I can refresh.
Oh,
Yep.
I see. Yeah, then you have to control memory, I guess.
Right, right. Okay. Now that we're done with that, let's return to the slideshow. Okay, we had 3 blue, 1 brown. Now we're up to this. Yeah, we've seen the hardest problem. What does the full exam feel like? Okay, the exam I took, the 2019 SAT. Now I'm going to set the stage again so you'll have full immersion. It's a cold day in 2018. Not as cold as the picture realistically, but we're considering the mental toll here that this fish has. You wake up a little before 6, eat breakfast while looking at your textbooks for the final time, try not to think about the test too much, and go to the designated test sites. Every year, Suning is held once in November. It is taken in one day for 8 to 9 hours, comprising the following subjects: language arts, this is Korean; So that's the first one we take, and then mathematics is the second one we take. And after that, you have lunch, and then you have all these other exams. This one is optional. I didn't take this one. So up till here. You can like pause. You can stop me at any point and ask me anything about SAT stuff. I'm fine with it.
We should have everybody take language arts and then Zai take classical Chinese. And
Right.
see how it works.
Everyone takes. By the way, I have to mention the language arts, the Korean language exam this year was the hardest it has ever been.
Oh no. I mean, it's not going to make
I
a difference
believe,
for us.
yeah, I believe more than 10,000 students gave up and left their exam site after the language arts exam. Anyway, another insane mental toll as you go into the math exam. Let's look at the. Okay, let's go to the. Oh, you get the exam papers, like big, creamy papers. And before starting, there's a long tradition in Suning. This part says it's a rudimentary way. What's this? Yeah. Oh, I'm sorry. I read my script. Write the following text in the certifying statement section in the answer sheet. This is a rudimentary way to check and compare your handwriting in case any problems occur. This year's certifying statement was exceptionally moving. It said, "Never have I seen one as lovely as you." Now, remember when I asked you to try the exam and I said I will give you a +1 point bonus if you write the phrase, "Never have I seen one as lovely as you" in your own handwriting and send it along the answers. Trust me, this is important. Yep. We've got all these amazing handwriting from the solvers, even a long one from Sunny. The phrase is from a poem by Kim Namjo, the poet of love, rest in peace, from a poem called Letter. There were no English translations, so this one is my amateurish translation attempt. Okay, I'll give you some time to read, probably. Should I read it? I'll give you some time.
I think you can read the Korean version so we can get a sense of immersion.
Oh, right. I should read the Korean version. Okay. 편지, 김남조. 그대만큼 사랑스러운 사람을 본 일이 없다. 그대만큼 나를 외롭게 한 이도 없었다. 이 생각을 하면 내가 꼭 울게 된다. 그대만큼 나를 정직하게 해준 이가 없었다. 내 안을 비추는 그대는 제일로 영롱한 거울. 그대의 깊이를 다 지나가면 글썽 이는 눈매에 내가 있다. 나의 시작이다. 그대에게 매일 편지를 쓴다. 한 구절을 쓰면 한 구절을 와서 읽는 그대. 그래서 이 편지는 한 번도 붙이지 않는다. Clap, 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 clap. Okay, thank you. Right. That was the letter. And now, like, you are so touched, you're moved, you're crying, opening this first page of the math exam. Okay, let's go. Time 100 minutes. Total score 100 points. 30 questions, 21 multiple choice questions, 9 short answer questions. The answer to each short answer question is an integer from 1 to 999. Calculators are not allowed. Bam, let's go. Let's go to the test. Okay, I have the test here too. Bam. This is kind of the format, it looks like. This is the bam. Let's see. I think I want to, since there are people here who have tried the full exam, I kind of want to ask you how you felt about the exam as a whole. Like, what were your expectations going in? What were, how did it actually feel? Do you think it lived up to the hype or no?
I mean, this
Or
is definitely harder than the standard like American SAT because I know like the standard American SAT, you're expected to get full marks.
right,
Like, as in like the standard is you should get full marks, and this one is just I mean, I feel like it could be practical maybe to get full marks. I mean, it's definitely possible. I've later tried the last question, which I wasn't able to finish, and it's not like terribly hard. But
right,
I,
right.
I couldn't do it, so that's yeah.
Yeah, yeah. Valo says it was hard mostly because the questions were so time expensive and so little time. Yeah, that's true. a lot of the part, like, yeah, I think a lot of problem design goes into making it so that there are multiple ways to solve each problem, and you can save time by doing something cool or intuitive or something creative or something like that.
I
One
think it's
thing that
also there's a surprising amount of statistics that when I like wrote up the solution document, I realized there's a lot of
Right.
statistics.
Yep. That's true for only this era. Like, the meta has changed a lot throughout the entire existence of Suning. Like, there's like I've divided it into eras. This is the website I made. Like, this is the new meta. You can see that 2019 is kind of an old meta for today. Usually, like, in these days, they have a completely separate section for statistics. So the main part of the exam handles only like arithmetic and
Ah,
basic calculus,
and
and
there's
then
no
they have.
part.
I'm
Like
sorry.
there's no distinction between the type guy and type na.
Oh, sorry. I'll go through that part just
Okay.
after this part. Okay. So right now the meta is like, there's a you can select between what type of elective things you want to do. Like, there are three types you can choose from. There's probability and statistics. If you choose that, you need to solve these 8 questions here. You can also choose calculus, that handles like calculus of trigonometric functions and stuff. You can take that. That's these 4 papers. And then you have geometry. If you pick geometry, you can do these 4 pages. Now, this is a new meta. The meta is also going to change in 2027. The meta changes a lot. Anyway, in my era, all those 3 elective types were in one test. So I had to take the 3 at the same time: probability and statistics, calculus, and geometry. So this contains probability and statistics as much as it contains calculus, as much as it contains geometry, which is probably why you felt like there are a real lot of statistics questions. Yep. And then you also asked about what this type ka means. So ka is just the first
I
letter in the
did
Korean
do
alphabet.
research,
Oh,
so
yeah.
I did do research, but like the distinction was removed. Yeah, in like the 15 reversion, or
Yeah. In this era, there was ka for people who wanted to go into engineering and stuff, and na, which is for everyone else. So this one definitely harder, covers more topics. Nowadays, it's all in one exam. If you want an engineering, you just choose calculus within the 3 elective types,
ah,
and that's what you do today. Now, if the meta changes again in 2027, the ga part will be completely gone. Everyone will only take arithmetic and calculus, no advanced calculus, in starting from next year. Yep.
let's see.
But anyway, that's what's happening right now. Uh, let's wait. Where's the thing? Bam. Okay.
one brief question. So I saw that you said that it was like 100 points total. How are the points distributed? Because I assume you might go into this with like favoring some questions over others or something.
Right.
Oh, cool.
So from 1 to 21 are the multiple choice questions. From 22 to 30 are the short answer questions. Each section is supposed to be in ascending order of difficulty. So 222, then 333, and then from here 444, all the way up to here. And again from 22, 3, and all the way up to 4. And the hardest questions are supposed to be this one, and this one, at least in this meta. Again, the meta changes a lot. Nowadays, it's not the meta. Anyway, that's how the points are distributed.
So you know that they're ascending, but as a student, you don't go into this knowing the actual point distribution exactly.
No, they are written here.
Oh, cool.
It's always
Oh,
fixed.
gotcha.
Yeah, it's always fixed within the meta. Now, yeah, usually you would just go from here to here, go on and on, and then if you get stuck, you will move on here and then try some of these. If you get stuck again, then you will look at harder questions and then try to solve them, stuff. Yeah. I think what we should do is I don't think we have to go through every problem. I think we can, because we're a math club, we only need to look at the mathematically interesting ones, right?
Let's
Uh,
start at problem one, which actually I think problem one is really weird. Like I don't understand what it means to take the sum of the components. Like it seems such a weird thing to ask for.
right. Let's say, okay, I've divided the problem into a few sections. This is the easy part, and the easy part is supposed to be like basically memorizable. Basically, it's very fixed in the way they present themselves, and yeah, this type of question has just been the meta for problem number one for a few years. And you just see this and you just know what it means. But anyway, I think it makes more sense in Korean. And I don't think, yeah, what is the sum of all components is really that big of a thing. But yeah, components is a concept that students learn. It's just these are components. So a
Because
plus 2b,
because
yeah,
I would assume that the components are just like you can break them up into vectors, so the components would still be vectors, so it would be weird. But like
yeah.
I guess the only natural interpretation is to just take them as treat them as scalars.
Yeah. And like because these early parts are so what should I say? They are so optimized that people tend to develop like ways to even like solve this faster. You probably just add this first, and do -1 times plus 2 times 3, and that gives us kind of a faster solution. Like just a mere seconds or two, but yeah, like you're
I think I
speed
do
running
that as
in this
well,
part.
which I find funny.
Yeah. Anyway, like these are speed runs too. You just look at this and you just write 3x instead of this, and then yeah, you just go like delete x, and then you get 5/3 and stuff. Yep. And then you have like internally dividing the line segment AB in the ratio 2 to 1. Uh, that's also something very like a minus 2. This has to be divided into a ratio of 2 to 1. And this has to lie on the x-axis, which means the y-coordinate has to be 0. So a satisfying this has to be 4, something like that. Yep, it's basically a speed run. Just to save time for later questions, you are correct. And even in this part, like, I believe the intention behind this expression is that you are supposed to recognize that A and B complement are mutually exclusive, means A is contained in B. But if I were a student like solving this exam, I wouldn't do this. I just have a fixed strat for solving this kind of questions. I just do this. I just write A complement, B complement. A and B complement are mutually exclusive. I just write this part is 0. PA equals 1/3. This has to be 1/3. I write 1/3 here. PAC, this B, this has to be 1/6. And PB, I add up these two. I do 1/2. And that's faster than thinking about mathematical concepts, and it's also like safer because the more creativity you have to think about, the more faulty you could get, I guess. Yeah, anyway, that's what happens in the earlier questions. I think the one I'm gonna touch upon is this one: parabola y squared equals 12x.
Oh yeah.
Now, yeah, parabola y squared equals 12x. Now, a parabola is defined as a curve where in any point in on the parabola, if you shoot a laser at this thing, uh, you're gonna get a what? I mean, if you shoot a laser from the focus to here, you're gonna get a line that's perpendicular to the x-axis. That's kind of a, I don't know, a definition of the parabola. Yeah,
Yeah.
and usually, I don't know if this equation is that well known to US students, but this thing is equal to 4p, where p is the coordinate of this focus. So here you can just instantly know, if you know this know this expression, you just instantly know that the focus is at 3.
I definitely don't know this equation, and took me a little bit of time to derive it, but it was possible. So that
Right.
it was quite painful. And I is it the norm to say y squared equals 12x instead of x squared equals 12y?
It's kind of weird because this is in the geometry section, and in the geometry section they weirdly use this more. I think it's because they want to have some like
Maybe
have
because
some
horizontal
something
lines
similar. Yeah, it
more.
looks similar to this. This is the hyperbola,
But
and
like,
if
why
you
would you want it to look similar?
I don't know.
But like, so I ended up doing like a changing x and y, and it just confused me a lot more. And
Yep.
this was
Also, maybe this is also less known in the US, but there's a thing called directrix here at a coordinate that's just a negative of the focus. And the directrix has this feature of being equidistant as the focus. So if you are on any point on the parabola, then these two lines have equal distance.
We were definitely taught this at some point. I just forgot the equation for it because it was in like
Right.
I think it would be equivalent to maybe 11th grade math or something like that. Yeah.
Right. Okay. Anyway, so the fastest way to solve this would be PF equals 9. This is 9. This is also 9. So the x-coordinate is, this is my negative 3, so this has to be 6. Yep. And then we could skip the next few questions. From here, it gets to medium. And this is where you need to think a little bit. So for example, here, you have a function, you have its inverse. What's the value of g prime of f of negative 1? Now here, if you ever get an expression like this, what you have to think about is that f and g satisfy this. F of gx is always x. G of fx is also always x. Now, this kind of looks similar to this, but there's a prime here. What if we take the derivative of both sides? We get g prime fx times f prime x equals 1. And that just gives g prime f negative 1 is just 1 over f prime negative 1. And that's how you save time here and do the derivative.
There's also a
Yeah.
geometric interpretation where you take the inverse as reflection across the y equals x
Yeah.
line, and you get the same result.
Yeah.
But when I did this, I kind of just went, I don't want to deal with this, and I just computed g prime, computed f of negative 1, computed g prime of that.
Yeah. I mean, that's the thing you can do. Like, as I said before, thinking about the concepts and actually trying to do something creative could result in making a faulty
Because I know this is
logic.
stuff that I am likely to get wrong, so I didn't want to mess with it.
Yeah. And there's some probability stuff. There's some equations, another more counting stuff.
I guess
Yep.
11 is
geometry. 11?
yeah, I was just mentioning 11 because this is I don't know how obvious it is how to solve this. Is this just like is this
You
just
you just compute the discriminant of this formula. It's gonna be like b squared minus 4ac.
like I guess it's
This is
obvious to a person that this is you just did directly take the discriminant change to sine squared. I like how it uses like quadratic stuff like twice, which is funny.
Yeah, I like that as well. These are some like pretty neat problems, I think. Oh, this has to be less than 0. And then there's cosine and sine, so you have to change cosine to sine
Yeah.
for it to work as a quadratic equation again. And then you solve this, and then you kind of draw out how a sine looks, and then you kind of try to deduce alpha and beta.
Yeah.
Bam. Yeah. 14. I don't think I really have to explain it. Yeah, I believe Sunny got this one wrong because of a mistake, but yeah,
That
it
was
was just a
stupid.
mistake.
Basically.
It was a simple mistake, so I could
I
but like
don't.
if I was taking the question, I would probably try to solve this question like 3 times because I know I could get this one wrong. I
I
know I can make a mistake here.
yeah. I don't know why I thought it worked that way, and I really don't know what happened. Basically.
Right, right. Yeah, like it looks simple. You kind of just do, yeah. This is equal to 2 to the minus f times g. This is equal to 2 to the minus 3g. And this just means minus fg is greater than or equal to minus 3g.
Yeah.
Take the negative away. You get that. And you have to you can't just divide it by g because you have to divide a case where g is positive and where g is negative. And that just, in the end, it ends up giving us 1, 3, 4, 5, I believe. Yeah.
Like I don't know why I believe that, if you like I kind of just believe that at 2, because f is 0, you get 0, which is less than or equal to everything, which is just not true.
Right. Yeah. I mean, I believe this question, a lot of students got this question wrong for a problem at number 14. I believe it was a very mistakable question.
Yeah.
Now, what's after that? Yep. Now we're getting
Definitely.
to the hard section.
Oh
Okay,
no.
this is where I think it really gets interesting. From here on, I'll try to at least mention all the solutions to the problem. Now, this one was unreasonably hard for number 16 at the time with the meta. I remember myself getting stuck here, uh, going to number 17 and returning here all the way after I've looked at all the problems afterwards. So I just had to reset my mind. I was not solving this at first. Right. So
I still can't believe I messed up use substitution that badly. I
right. I believe there are 2 solutions to this. Not as in 2 different solutions, 2 different answers. I just mean 2 ways to solve this. One is noticing this and trying to do some sort of x equals 1 over u substitution. It kind of works, but you have to be creative. You have to recognize that it kind of uh, adds up to something. Okay, if we make the substitution, it ends up being something like this, I believe. Yeah, if you make this substitution, then this is equal to this. But then this again, this alone is not enough to solve it because like even if you try to divide this into 1 to 2f and then plus half to 1f and then only substituted this part, that's going to give you something like 1 to 2 fx plus 1 over x squared f 1 over x dx. And this is not this because there's this 2 here. And I believe this is the first thing I tried in the tests while I was checking the test and I got stuck.
see.
Yep. But what you can do is just let this be I, and then have 3i equals this plus this plus this. And that just gives us 2fx plus 1 over x squared times f of 1 over x. And then this just solves to this. Now, that's one solution. I went through it pretty fast, so I don't think everyone would have gotten it, but that's because I wanted to talk about this next solution because I think the next one might be dare I say a more complete solution because what you can do is notice that this holds for all x larger than 0. Just plug in 1 over x to x. Like just plug in 1 over t. Then you get 2f 1 over t plus t squared ft equals, what am I doing? Equals t plus t squared. We did this substitution. And now, this is where it kind of gets creative. Like, look at this. Fx, f1 over x. This is fx. This is f1 over x. This is just like a linear equation with two variables and two equations. You can just solve this completely and just get what fx is. This is just like, these are variables. You just like subtract this from this, and then you just get fx. And then you just compute fx dx.
I mean, in fact, you can like multiply x squared to the original equation, and then you just get something that's way nicer.
Right. That's true. You just get 2x squared, and then this is 1, this is x, this is 1, and then
And then the
what do you
solving
do?
would
Yeah.
also be much easier.
This times 2, subtract from that, whatever, something like that. Yeah. And that's going to just solve fx. Now, the next one is a proof question. This is a long one. You are supposed to read through a proof and follow it. This is they have been pushing this for a while. I think this existed from the start of Suning. These type of questions. They really like to test students whether they are able to read a long proof. I mean, it's not that long, but to read a long proof and understand what the proof is saying. It's a like pretty interesting proof, like not that complicated. Of course, it has to be something that a high school student is familiar with. All the logic has to be familiar.
I think I've seen this exact question, just like without the intermediate steps, like just asking for the answer in like some competition math.
Oh, right.
It's like definitely after 2019. So
Right. Yeah. If they like remove this part and just ask it, then I guess it will be like a more of a math competition test.
this would be like
Question.
question 20 or something.
Right. Yeah, in this test. And then here we have some sort of geometry with limits. Now, this one, you are supposed to just do all this stuff. Yeah, like the correct way to approach this is just to AB equals 1. You just all it's telling you to do is find the area of this part, find the area of this part. All you do is actually just write out all the things. Tangent theta. This one is like 1 over cosine theta. And then these two angles are the same. So this and this has a ratio of this and this, which is like, this is sine over cosine. So it's actually 1 to sine theta. 1 to sine theta. And you just do this and get the length of this part, get the length of this part, get the length of everything else, get the length, just compute the area. All the things is what you're supposed to do. But after you do that, sorry, yeah?
No, I was just laughing at how this is like just I think completely implausible to do if you're actually like wanting to finish everything in time.
Right. Oh, no, but I actually want to say it's very risky for students to go for intuitive solutions in a question like this. Because
That
even
is
for
true.
even for this question, the only reason an intuitive solution that I'm going to show from now on works is because this part only consists of division and multiplication. Like, if anything, like if there was an equation like, I don't know, this, I don't know exactly what it's going to be. Maybe this. Like, if it told us to calculate something like this, if there's a subtraction or addition or anything, then all the intuitive solutions kind of crumble down, because
Yeah.
then you kind of have to like go for, I don't know,
I mean, I would probably
Taylor
take
expansions and stuff. Yeah.
Oh yeah, because well, yeah, right. But like, I also think a question is not going to do that. But yeah, it's definitely very worrying to do things intuitively when you have limits, because
Yep.
it's like even if
And
that.
yeah, I so I think like I want to say that this is usually where students use the time that they have saved in the first part. Because I
I see.
think even the like private tutors tell students to actually write all the things down, because it's so easy to make a mistake if you try to like actually send theta to 0 and try to draw what happens and stuff. Like, it's so easy to make a mistake. So yeah, I think I solved it like this as well when I was first doing it in the exam site. But yeah. Anyway, after you solve it, there is a way to kind of intuitively check if the solution is right. What this one is telling us is find the area of here and here when theta approaches 0. Now, when this angle approaches 0, this triangle is going to look like this. Something very thin. Theta approaches 0. This is a right angle. This is also going to approach a right angle, almost 90 degrees. This is supposed to be dividing this angle in half. So that is going to approach 45 degrees. Like, this is almost going to be equal. Now, this is 1. This thing is going to look like this. And this thing is going to look like this. Now, because this and this are equal, and this are also equal. We're just going to say that they're equal. Now, this part, let's start from here. The length of this part approaches theta, because this is 1, this is theta. This is basically the arc length of like radius 1 angle theta. This is just almost theta, which means this is also theta. This is all theta. The area of this sector is going to be half times r squared. That's going to be this squared times theta. Now, this r is 1 minus theta. This part is 1 minus theta. But that's basically 1 because theta is approaching 0. So r is basically 1. So the area of this part is just half of theta. And the area of this part, this is basically a right triangle with length theta and theta. So this part has an area of half times theta times theta. So that's going to be this. And now you just plug this here, plug this here, and you get, what's it? Quarter theta squared over half theta squared, and you get a half. And you are not supposed to solve like this. This is only supposed to be used as a way to check if your intuition is correct, if your solution is correct. Anyway, that
But like,
was
I guess
question
this
number
this
18.
does work. Like, surely this isn't that bad. I can see how it breaks down when you do add and subtract, but also, this is like an intuitive method that kind of just doesn't. Also, just fails intuitively when you have add and subtract.
Yep. Also, this is kind of on the easier side of these kinds of questions. So if it gets harder than this, then sometimes your intuition is like kind of gets confused
And
if there are
it's
more
safer to
complicated shapes.
and it's
Yeah.
definitely safer to just do it than.
Yep. Okay. 19. I'm just going to do the first half of 19, which is there's a tetrahedron ABCD whose face BCD is an equilateral triangle with side length 12. Let H be the perpendicular foot from point A to plane BCD. So we know that BCD is an equilateral triangle.
Wait, no,
Just
Zai,
draw
this is a
that.
perfect opportunity. Can you construct a perfect equilateral triangle in Excalibur? You can.
Perfect square. Turn it 30 degrees. I mean, I need to copy it first. turn it 30 degrees.
Can we just
have
do
this thing
straight edge and
Yeah.
compass constructions?
I don't think so. Wait, I need the thing to be even. But
Because you
yeah,
could like
I
take
think I
a,
just do.
you could just make a circle and then like make.
You can't take the intersection that easily. I'm not sure if compass straight edge would be good.
Okay, first, the shape of the circle is not promising. View mode, where's the thing? Oh, disable Zen mode. Just do that. I don't think it's gonna work. I don't think it's gonna give me anything
I
useful
think I
about
know
the
of a way to do
intersection
it.
points.
So if you take a line segment and then you make 2 circles, one at each side of it. Centered at each side of it.
I think yeah, TwoSoft just wants the compass straight edge construction, but then you kind of have to take the intersection of the 2 circles, which
You don't have to.
can't.
Sorry. You're saying. Oh, Excalibur doesn't allow you to do this.
Yeah.
Yeah.
Is that not legal in the
I
rules
think
of
the way to
construction? We can't just use that point.
unfortunately, for all rules of PowerPoint construction, I don't think we have allowed that
Oh
yet.
no.
So I think the way to do it is to rotate this square by 30 degrees. That's going to give us something like this. We know this is 1, so this is a half. This is √3/2. And this is another half. So this whole thing is 1 plus √3/2. And now we do subtract 1/2 from this length, which is this. Oh, wait. How do I snap it to that? I don't think it's possible yet. I have to look more into it. Okay.
This is possible because Excalibur has a snap to objects. If you right click the canvas, it has a like it's kind of like a toggle grid option, but this snap to objects.
Oh, right. In that
And
case, we do have √3.
So I actually did this construction when I was making the graph for this thing.
Right. Okay, this is √3, given that this is 1. This is 1, this is √3. Bam. Anyway, back to the triangle. I'm just gonna eyeball the triangle with the pencil tool, B, C, D.
Yay.
Just as Kais intended. Now, H is a point inside triangle BCD such that triangle CDH has 3 times the area of triangle. Okay, let's look. H. Triangle CDH has 3 times the area of triangle BCH. So this is like 3A. This is A. Triangle DBH has 2 times the area of triangle BCH. DBH, this is 2A. AH equals 3. Okay, let's ignore that part. All I want to ask is this. What do you think is the best way to determine the position of this point H, given that this is an equilateral triangle with side length 12? This is A to 2A to 3A. Interesting. By the position, I mean, like, for example, the distance from this point to each of the 3 sides. Bam, bam, bam. Does anyone have an idea on how to calculate these lengths?
Wouldn't it just be factors of 1, 2, and like if A is... Yeah, I think just the height of it would have to be ratios of 1 to 2 to 3.
Right. Because these are all triangles with the same
base is the same
length.
Yeah.
Let's write K, 2K, 3K. Okay, now the next question is, how do we get K? How do you think we can get K?
I don't know if I probably missed some details, but I think we know the area of the entire triangle, so that means that we can just figure out the whole area and then divide it all by 6 and start multiplying by
that. That's correct. Yep, the entire triangle. It's an equilateral triangle, so what was it? Like something like this? Yeah. And then that is equal to, I mean, 6th of that is equal to this little triangle, because a plus 2a plus 3a equals 6a. So this part has to equal the sixth of the entire triangle. And that's how you get k. And after that, it's just geometry after geometry, and you can get the line segment AQ somehow. Bam, bam, bam.
There is a separate approach where you can extend BH, CH, and DH to meet at the other side. So, for instance, if you extend BH to meet at, let's say, I don't know, choose your own letter, then you can get C to that point. So if you extend BH to, let's say, E, then you can get CE to ED is equal to the ratio between the areas of BCH and BHD. And therefore, you will be able to get CE and CE to ED.
Right.
Because CE to ED would be equal to the area of BCH and the area of BHD, and this allows you to get all of these proportions, and you can solve similarly.
Right, right. And yeah, I've read through the solution by Sunny, and there's a theorem that I didn't know the name of, but yeah, there it was a great
There's a
solution.
lot of area manipulation. Like the theorem itself is also just fiddling with areas.
Right, right. Okay, that was problem 19. Okay, we're going toward the end of the multiple choice section. 20. Now this here is where I think it gets like harder. I'd say harder. You usually say killer problems in Korean SAT. Killer problems. This one is like semi-killer. This one would be killer. This is also an easy problem for a killer, but anyway. Oh, by the way, did I mention like this test was not that hard as the Korean SAT math in terms of Korean SAT math. This exam was slightly easier than usual. Slightly easier than usual. Anyway, back to the question. Consider all lines passing through some point that are tangent to the curve y equals sine x. Now, I think we are supposed to draw sine x, kind of. Now, the point minus that's here. And we are supposed to draw tangent lines like this. Bam. Whoops. Bam. Bam. Something like that. And let an be the nth number in this list, like all the x coordinates of the points of tangency. So this is a1, this is a2, this is a3, and so on. Pretty interesting. Now, which statements are true? Tangent of an equals something, something. Now, the only thing we know about an is that it's tangent like this. So there's an equation I use when there's there are these kinds of tangency. What I use is that the rate of change. There are two kinds of rates of change. There's the instant rate of change, and there's like a, I don't know how you call it in English. There's like an interval rate of change. Anyway, what I'm supposed to say is the slope between this point and this point is equal to the instantaneous rate of change at this point, just the slope of the tangent line to this point. And this function is y equals sine x. So the prime of that function is just going to be cosine x. That's the instantaneous rate of change, right? Average rate of change. Okay, right. So what I'm going to do is write down the slope, the equation for the slope between these 2 points, which is x minus x, then y minus y. That's the slope of this line, which is equal to the slope of the line at this point, which is cosine a1. Now, This minus 0 doesn't need, you don't need that. Put this here, put this below here. You get sine over cosine, which is tangent. And that gives this equation. So this is true. Yep, this is similar to problem 3 from before. Yep, this also uses the rate of change thing, slope thing. It's often used in like these sorts of situations when you have a line tangent to a curve and you have 2 points on a line. Now, after this part, you can kind of think about what these things do and then stuff, but I think the best way to solve, intuitively solve this part is just to draw this again, which I mean like draw tangent. Draw the tangent curve like this. kind of bad drawing, but anyway, this is tangent x, and we're gonna draw a line which is x plus pi over 2. This is pi over 2. Now, the fact that this equation holds for all an and means that these are just an. These coordinates are just an. a1, a2, a3, and so on. Now, drawing this kind of gets hard, so let's just open up Desmos. Desmos, okay. Y equals tangent x, and then y equals x plus pi over 2. And cheater, okay. Let's see. So this is how the thing looks like. This is a1, this is a2, this is a3, this is a4, and so on. I mean the x coordinates. Now, what it's asking us first, tangent an plus 2 minus tangent an, is it larger than 2 pi? For example, tangent an plus 2, like the difference between the x coordinates of these two, is it larger than 2 pi? Now, maximum cheating? Okay. Bam. Now, observe how this is 2 pi, because tangent has a what it repeats every pi.
Period.
Right? Yeah, period. Period is pi. This is 2 pi. This has to be more to the right than this. So this is true. Now, then let's look at this one. an plus 1 plus an plus 2 is larger than this. Now, what you have to do here is that, I mean, you can just do it as just like this, but you can also move these around and have an plus 1 minus an. Is it greater than an plus 3 minus an plus 2? And this is basically asking, is this larger than this? Is this larger than this? Now, you see the tangent kind of gets steeper and steeper as you go this way. Yeah, this seems totally viable. Yep, true. I remember I vibed this question out using this drawing. It just because the tangent gets like steeper and steeper as you go to this side, this just approaches pi more and more. The difference between this part and this part, like the difference between this part and this part, this little part is just gonna get closer and closer. It's just gonna reach 0. Yep. And I think that is enough intuition to just say that this is correct. Of course, you can do like calculus and stuff to check that it's correct, but yeah, I think that's basically why it's correct. Okay, number 21. Now, I believe this one was hard for some people. Bam, 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 bam. The first one seems plausible and the others fall out. Yeah. True. Okay, let's go a function fx differentiable on the set of all real numbers satisfies the following. What is the value of f -1? Huh. And this is a kind of a new question. I've never seen this exact equation before the SAT. But when you get f and f prime at the same time, usually what you want to do is integrate. Because when you differentiate f, that's why you get f prime. So if you can find a way to integrate this and remove f prime, then you're going to be left with a much more simpler equation. So, oh, by the way, this is not a set symbol. It's just like a parentheses.
It looks like you want to put the 2 on the right side so that then the left side just integrates naturally. Wait, sorry, just kidding.
Right. Okay, you can do that too, but I think this constant will not matter that much when you integrate. Because
sorry.
Imagine
Never
you
mind.
are imagine you are taking the derivative of f to the power of 3. The curly brackets are just supposed to be parentheses. It's how you write things in Korea. You just write them as parentheses. Yep, just grouping. Korea uses all kinds of things to group things. You just use this one first, and then this one, and then this one. China has this? What? That's the ordering is different?
That is
Okay,
what I
is this
learned as a
China?
child as well.
Okay, that's an interesting difference. This is Korea.
Interesting. I mean, I think these notations are equally bad.
Right.
Yeah, ideally, if you typeset your math well, then it'll be readable regardless, but not everybody does that.
Here, okay. Let's integrate both sides. You know how, if you try to take the derivative of this, you get 3fx squared and then f prime x. And this part is basically just this. You just have to multiply, what's it? Multiply 2 over 3 like this. And then you know that this is the antiderivative, one antiderivative of this. And this part is very similar, but you also need this 2 in front of the x. Wait, what just happened? My XCalibur bugged. Where did all my... Where did it go? Where did it go? Okay, it's fine. I have it saved. Bam. Okay, so this becomes like this. And then the right side becomes this is what it would be if this 2x didn't exist. But because this exists, you have to multiply this with an additional half. Because that way, when you take the derivative, this 3 is going to cancel out with this, and this 2 is going to cancel out with this. And then you are going to be left with exactly this. And then, of course, since we are taking the antiderivative, we need to put a plus c there. We can like do something better. We can multiply both sides by 3 and also multiply both sides by 2. This becomes 4. This technically becomes 6c, but c was just a random variable we picked, so it doesn't matter. This is the what we get by integrating both sides. And now we know this, and we need to get this. And here is where it gets kind of creative. You need to play around with numbers. This is like basically number theory at this point. how do you get f of -1? Like, realize how if you put -1 here, this becomes -1. This also becomes -1 because -1 is a fixed point of the line 2x plus 1. 2x plus 1 looking like this. Yeah. It passes through like -1 comma -1.
That should be under the x-axis.
Oh, sorry. -1 comma -1. What am I doing? Bam. And that gives us like, what is it? 3 f to the -1. I mean f -1 to the 3 equals c. So now we just have to get c, and that's gonna give us the solution. Just a Quark sees it. Just a Quark. What did you see? Bum, bum, bum.
I see that if you take 6, f of 6, and kind of like reverse the 2x plus 1 3 times, then you get a -1/8.
Right. Or in other words, if you put -1/8 in here and take 2x plus 1 of it 3 times, you get 6. Yeah, it's weird.
Wait. Say that again? You do what?
You put -1/8. Like, imagine this is 2x plus 1. This is x. You start from -8. You put it in this function. You plug that amount again. So you're doing this. You were kind of doing this, and you
Is that
arrive
second
at
entry
6.
6? Oh, you arrive at 6. Wait, so what are the intermediate
Okay,
things there?
let me show you. 4 f to the -8 cubed is equal to, put -8 there, you get -1/4 plus 1, 3/4. Okay, and then we're gonna put 3/4 in that again. F 3/4 cubed is equal to, put 3/4 in x, 3/2 plus 1, 5/2, and then we put 5/2 inside here again. Then we get times 2 plus 1, f6 cubed plus c. And that's how we can get c, because let's say this is 1, this is 2. We know that this is 4 minus c, 4 minus c. Plug it in here, 4 times 4 minus c. So 4 times 4 minus c is equal to this. And we get this 2. So we get 2 equations with 2 unknowns. So we can get c. Let's just do 16 minus 4c. And then move the c aside, 5c. And then plug this in here. So 16 times 4 minus 5 times 4, c equals 2 plus c. 21c equals 62, right? C equals, wait, am I wrong? Did I do something wrong? Because I don't think this is the
Yeah, this
answer
definitely
I
doesn't
got.
seem right.
Wait, where did I make a mistake? 16 minus 5c. Wait. Oh, f6 is equal to 2. I was supposed to plug in 8 here because this was f6 cubed, right? This was f6 cubed. This had to be 8 plus c. Now we get 21c equals 56. C is equal to, this is 7 times 3, 7 times 8. And that is c. And remember how f minus 1 was the fixed point of this 2x plus 1 function. We plug in -1 here. We just get 3f minus 1 cubed equals c. And then this is just 3/8, 9/8. We get 2 and then 9 to the 3rd root. And that's going to be 2 times 9 times, what is it? This is 3 to the power of 2/3. So that's equal to something like this.
Yeah.
And yeah, that is this. So it's number 4. Sunny says, if you let fx equals gx plus 1, you get 4gx cubed equals g2x cubed plus c. Right. So fx equals g. Wait, do you do it at this point?
Yeah, I do it here.
Right.
Well, you
Right.
get 4 times g of x plus 1 cubed equals g of
Yeah.
2x plus 2. But then
Yeah.
you can just rewrite x plus 1 as x.
Right. And then that's basically 4gx cubed equals g2x
And then if you
cubed
plug it
plus c.
to -1/8 and 6, you get 7/8 and 7, which is more obviously solvable.
Right. Yep. That makes sense. That makes sense. Anyway, it all has to do with this image, I think. I mean, of course, you're not supposed to draw this to solve it. You're just supposed to plug these in, but yeah. They meet nicely. -1 goes back to itself nicely. Cool problem. Okay, that was problem 21, hardest problem in the multiple choice section. And then we have all these, only a few, 9 questions left. What if we had other values? Would we be able to solve it? Not within the definition, like not with just the method we did. And I don't know if this solves as a differential equation nicely into anything. And I don't know if we can actually get f, but it is differentiable on the set of all real numbers. So I don't know. I think maybe it becomes something nice. It's meant to be something nice, maybe. Yeah. Sunny thinks no, you can manipulate the differentiable function pretty much arbitrarily.
In a way that still satisfies the first constraint?
Yeah, I don't know for sure because it's like one value of x is affecting another value of x to be something, right?
Surely, if you take, let's say, my g, and then you just say, I take, like, let's say, a log base 2 before my g, and then I subtract by the necessary constant, then it's really just equivalent to finding a periodic function. And it just so happens that I have the periodic function at like two different places which correspond to the same period, and therefore I can solve. But if it's not on the same
Right.
period, I wouldn't be able to solve for C, like, at all.
Right. Right. Okay, I kind of get it. I get the argument. I do believe like it was not considered while making the problem because that's not what students are meant to do. It's not even in the textbook, the part differential equations and stuff. Yeah, I don't know. Let's go to the short answer questions. And the first part is really easy. It's easier than the multiple choice questions. This part is also pretty easy up until 28. 28 has something interesting, so I'll just let's take a look. Consider this ellipse. Now, this is a square of the coordinate of this point. 33, that's a square of the coordinate of this point. And 49 minus 33, which is 16, is supposed to be the square of the coordinate of the focus. So this is 4. Now, 4-point P on the circle, bam. So it's a circle with a center on Y3 and with a radius of 2. Let Q be the point where with a positive y coordinate where line f prime p meets the ellipse. And now it says compute the greatest possible value of pq plus fq, which is this plus this. it looks daunting, but what you have to recognize is that an ellipse has a nice feature where any point, if you connect it to the two foci, if you connect it to the two foci, the length of f prime q plus fq is always equal to the major axis of the ellipse, which is 14. So this is simply 14 minus f prime p, and just as Quirk said, maximizing this is equal to minimizing this because of the negative here. Yeah, so we need to minimize this length. And how do we minimize this length? Hello. We can minimize this length by thinking about this triangle, connecting this point to the center of the circle, and then connecting the P to the center of the circle. Now, we know that this length plus this length is always larger or equal to this length because of a triangle inequality. And this is the same as this because it's the radius. So the smallest f prime p can get is when f prime p is on a line that extends to the center of the circle. If p is here, then this length is smallest. So all we have to do now is get this length. And that is easy because we know the coordinates of this and this. So this just becomes a right triangle with length 4 and 3, which gives us 5 here. And we know that the radius is 2, so this is 2. This is 3. This is 3. 14 minus 3 is 11, and that's how you solve question number 28. Bam. So the context here for Sniffer is that we are solving the exam, Korean SAT math exam I actually took in 2018, and we only have 2 problems left, the 2 hardest problems. And after that, we're going to have a fun session where we solve Korean math questions in Korean. I prepared a lot for it. Okay, 29 is fun and 30 is daunting. 29, I'm gonna leave. Yeah, I'm gonna leave the hardest for the last. 29. We have a triangle ABC on the XY plane with an area of 9. Bam. Okay. Let P, Q, and R be points that move freely on line segments AB, BC, and CA respectively. The set of all points X that satisfy AX has to satisfy quarter of AP plus AR. Now, P, Q, and R are points on here, here, and here respectively. Now, Yep, Sunny Sniffer, I believe it is solvable without any dictionary. I believe I have like a few questions prepared and I've selected them very carefully, so I think it's possible. Okay. There are multiple ways to do this, but I'll talk about the way I did it in the actual exam. So AP plus AR. Let's just think about like this thing looks weird. I was playing around with what does this half and a quarter mean for a while, and I thought maybe it's supposed to be something like this, and what I did was this equation is the same as doing this, right? And I think I thought the concept behind it is that you are supposed to take this median, the mean, this mean, and then you are supposed to take another mean. Let's say M is the midpoint of P and R. Then we know that 2 AP plus AR over 2 is equal to, the vector, AP plus AR over 2 is equal to the vector AM, because this is the mean. And this just becomes AM. Now, this is another kind of mean thing. So let x be the midpoint of m and q. Then this entire thing just becomes ax. So that's what I thought this expression is entailing. We are supposed to take the midpoint of p and r, and then we're supposed to take the midpoint of m and q. And we need to find out where that point x can lie. And we need to take the area of the region. So for example, if p happens to lie here and r happens to lie here, then the mean of that is just going to be here. Okay, let's think about all the places m can go first. M is the mean of p and r. Now, let's say p goes all the way up here and r goes all the way down here. Then m has to lie here because that's the middle point. If p is here and r is here, then m happens to be here. Like if p is here and r is here, then m happens to be here. And what you have to realize is that m can travel anywhere in this region if p and r moves freely on these two line segments. That is because for any point p, like let's say this is p, and let's say r moves from here to here smoothly, what would happen to m? It would surely move from the midpoint of these 2 points to the midpoint of these 2 points freely. Like it's going to move in a line like this. And these lines, when you add up all of those lines for every p on this part of the line segment, then it becomes this entire diamond. It fills up this entire diamond. Now, the way I just explained it is maybe not the most intuitive way of explaining it. I just use this way because that is the way I first thought of when I looked at this. But anyway, that's how I got that m can be any point lying on this diamond, and x can be any point lying on a little hexagon like this. I'm not going to explain why this happens, but I'll just say, yeah, x in the end, it happens to lie on a hexagon like this. And that's because this diamond gets shrinked in half towards q and moves with q. So yeah, the geometric intuition behind it is that this diamond, when q is all the way here, this diamond shrinks half the way from this original size to the direction of q, which becomes something like this. And then if q is all the way here, the diamond becomes something like this. And this diamond moves freely from here to here and swipes over all this area. So in the end, x can lie within this diamond shape, which is kind of like, imagine we divide this up into tiny triangles. Then this hexagon consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10
Somebody clip that.
triangles out of the entire 1, 2, 3, 4, 5, 6, 11, 16 triangles. So the area of this part is 10 divided by 16 multiplied by the total area 9, which is 2 times 8, 2 times 5, 45 over 8. Compute p plus q, 45 plus 8. That's what you get. Okay, we have only just one question left. What do you think? Do I need to go through the full solution, or should I just lay down the intuition behind some parts? What do you think?
When do you want to sleep? I think is the question.
Okay, wait, what time is it for you people right now? If it's okay for you, if it's not like time to sleep for you, then
It's fine for me, but I'm just worried about you. It's like
right.
what
It's 11 a.m. here, so
Right. Okay, then I'll go through this one fast. and only lay out the fun parts, which is the one at the start. And okay, let's do this. There's a little hill here, and I'm traveling on the hill. Imagine I go like this in this hill. What's my height gonna look like with respect to time as I travel? Number 1, is it gonna look like this? Number 2, number 3. Pretty easy question. What do you think? What number 1, number 2, number 3? If I go like this, what is the height according to time gonna look like?
Number 3.
It is number 3 because I go up and down once, then I go back, I go up and down once again, I go forward, I go up and down again, up and down, up and down, up and down. That's gonna be the basic idea behind this problem. Let's look at this. Fx is a cubic function, leading coefficient of, oh my gosh, 6 pi. But it looks like this, or this, whatever. Gx, oh my gosh, 1 over. Now, I would say Fx is really is an eyesore here. I kind of want to write it as something like this. I want to kind of write out as a composite function of this and f. So I'm going to do f of x first, and then I'm going to put that value inside this function, 1 over 2 plus sine x. Now, 1 over 2 plus sine x, how does that look like? At least we can draw this, right? We can't draw this because we don't know what fx looks like, but at least we can draw this. Sine x goes this, up and down, up and down. 2 plus sine x, just this, but 2 up, right? Starting from 2, up and down, up and down. And then 1 over 2 plus sine x. That's going to like reciprocal of 2. Like this is 3, this is 1. It's going to go, I guess, down, up, down, up, down, up. And then this is probably going to be 1 over 2. This is then 1 over 3. This is probably 1. Yep, that's how 1 over 2 plus sine x looks like. Now, what am I doing? Let us list all values of alpha for which gx has a local maximum or a local minimum at x equals alpha. Okay, so gx has supposed to have a local maximum or a local minimum. Like, at this point, we can try to like take the derivative of this and find out where it's local maximum or local minimum. But what we can also do is think about f as this trajectory. It goes up, down, and then up, forward, backward, and then forward, right? What if we traveled forward, then backward, then forward on this hill? When would gx have a local maximum or a local minimum? Now, I'm going to cut to the chase because I said this was going to be fast. The first thing I did is that I realized that when this has a local maximum or a local minimum is the same as when sine x has a local maximum or a local minimum. Because this is just bloat. This bloat is not needed. It goes up and down. This goes down and up. It has local maximum, local minimum, exactly at the same parts as this thing, sine x. We can just ask, what if we travel in this trajectory in these hills, right? So that's what we're doing. And then all we need to do is look at all these constraints and pick up all the things we need to pick up and apply logic. And that's gonna solve the question. I kind of want to leave it as kind of open for people on YouTube to try too, because if I lay out all the solutions, then I guess they have nothing to go for. So yeah. Anyway, that's how you solve 30. And that's how you solve the entire exam that I took as my SAT. Yay. Okay. Now, you can go sleep, but there's something really interesting after this. You know what's after this? There is, if we have time, we have the Korean Decipher Challenge, right? We have the Korean Decipher Challenge, and bam, bam, bam. Again, I'm gonna read this again. 2Swap once said, what if we have to solve the problems in Korean too? And it's a great idea. The math club really likes challenge like this. I prepared a set of problems in Korean that I think makes sense as a decipher challenge. Everyone will turn on their mic. I'm gonna share an DrZye link with the problems, and I'm gonna let you do your thing. Sounds exciting? Sniffer
Yes.
says no.
Yes.
Okay, then I'm gonna prepare.
I gotta get my.
I
Now.
okay. I need to reset this thing. Open a new thing. Bam.
I guess this would be a
Okay.
good time to ask Zai. How did you do originally on this? Did you get full marks or?
It's a secret. It's open to interpretation.
Okay, I see.
Now. Okay, I'm gonna share. I'm gonna export the link. I have it open. I'm gonna send it to the Discord chat right now. Let's see. Okay,